What happens when two substances with different specific heats are mixed? Have you ever wondered what happens when you mix hot and cold liquids? It's a fascinating process that involves heat transfer and temperature changes. Let's break it down in simple terms. When two substances with different specific heat capacities are combined, they will exchange heat until they reach the same temperature. This final temperature is known as thermal equilibrium. The specific heat capacity is the amount of heat needed to raise the temperature of 1 unit mass of a substance by 1 degree Celsius. Since different substances have varying specific heats, they absorb or releases different amounts of heat for the same temperature change. In this scenario, the hotter substance will lose heat, while the cooler substance will gain heat. The final temperature of the mixture depends on the masses, initial temperatures, and specific heat capacities of the substances involved. To put it simply, if you mix hot water with cold water, the final temperature will be somewhere between the two initial temperatures. The exact temperature will depend on how much of each substance you have and their specific heat capacities. There is a principle called Richmann's law of mixtures that helps us understand this better. It states that the heat lost by the hotter substance equals the heat gained by the cooler substance, assuming no heat escapes to the surroundings. The formula for calculating the final temperature is as follows. The final temperature equals the sum of the mass of the first substance multiplied by its specific heat capacity and initial temperature, plus the mass of the second substance multiplied by its specific heat capacity and initial temperature, all divided by the total heat capacity of both substances. If both substances have the same specific heat capacity, the final temperature will simply be the average of their initial temperatures, weighted by their masses. However, when the specific heats differ, the final temperature will be closer to the initial temperature of the substance with the larger heat capacity. This principle is not just theoretical. It has practical applications in everyday life. For instance, when you add hot water to a cold bath, the resulting temperature is influenced by how much water you add and the specific heat of each. In fields like cooking, chemical engineering, and climate science, understanding how different specific heats affect temperature changes is essential. It helps in controlling processes and improving energy efficiency. So, the next time you mix two substances with different specific heats, remember that heat will transfer until they reach a common temperature. The final temperature is determined by the masses and specific heat capacities of the substances involved, reflecting the fundamental principles of thermodynamics.